So in our today's class, we'll continue the fourth state of matter as well as fifth state of matter, and then we'll compare solids, liquids, and as well as gases. Like what is a comparison between them? After that, we'll discuss measurement of temperature. Now, let us see that we'll continue the last class. So what we studied in our last class. So we notice it last class we discussed what is the gaseous state and the properties of gaseous state. Am I correct, everybody? All of you? So please respond. And we discussed the certain properties of gases. So if I have taken the properties of gases, can anybody tell me what is the first property of gas? Everyone? No definite? All of you?
Shape.
No definite shape.
Yeah,
No
no
definite
definite
shape.
shape. And as well as second
No
property,
definite volume.
no
No
fixed
fixed
volume. Yeah, okay, no definite volume or fixed volume. And third property, all of you,
highly compressible.
Highly compressible.
highly compressible. And fifth one,
Thermal expansion.
thermal.
Thermal expansion.
Yeah. So highly thermal expansion or low? Thermal expansion is very high or low? Very, very high.
High.
Cubical
High.
expansion. Next, low density.
Low
And the next one, yes, please.
Diffusion.
rigidity and fluidity.
Rigidity and fluidity. So rigidity is very less or high?
Fluidity is
low.
high, sir. Rigidity is less.
Fluidity is very, very high. So next, we studied that
Diffusion.
property.
Diffusion.
That is what we used to call as diffusion. So diffusion is more or less compared to solids and liquids.
More.
More. So diffusion is more faster. If you take this, all the reason behind everything is just only one thing. That is the distance between the particles is more and the force of attraction is less. Yes or no, everybody? Yes, please.
Yes, sir.
Yeah, that is
Yes,
one.
sir.
Now let us see the last property in our today's class. So that, and then we'll continue. So that is what eighth property. All of you write it. Gases exerts pressure. Of course, these all the things we know. Gases exerts pressure. So now if you notice it, let me see. This is very, very important one. Observe very carefully. Okay. So observe very carefully, all of you here. So gases exerts pressure. For example, if I take the solid, all of you observe very carefully. What is this actually? All of you? It is actually solid. Now, if you observe very carefully, solids will exert pressure on the surface only from the bottom. Understand, Mr. Mari, what I am saying? So if you take this is the surface, all of you observe, surface, if this is only the contact surface only will exert the pressure on the bottom. Is it okay, everybody? Solids always will exert the pressure on the ground or surface wherever it is contacting. Is it okay, guys? Please respond. Because they are having a rigid surface, rigid shape. Okay. Now, if I take the liquids, we all know what is the properties of liquids. Anybody can tell me? Liquids can move within the liquid. Always they can move randomly. Is it right or wrong? All of you? Yes, please. Nobody will answer. All of you respond.
Yes, sir.
So liquids can exert the pressure within the liquid because they can move any direction randomly inside the boundary. Means within the liquid, they can move from one place to another place here and there and all. So observe, liquids always exert pressure between every particle. Suppose if I take this particle, this will exert pressure this side, it will exert pressure this side, it will exert pressure this side, it will exert pressure this side. So the liquids, it will exert the pressure in all the directions. Now, if you take it here, gases. So gases also, observe all of you. So as it is, the particles, the distance between the particles is more or less. That is what interparticle space. All of you respond.
More.
The interparticle space is very, very high. So is there any open surface for gas? Everybody? Is there any open surface? Please
No, sir.
respond. No. So as the particles are very, very far each other, all of you remember, the collisions between the particles is more. Okay. More number of collisions will take place. They will collide with one another and as well as with the walls also. Do you understand? So the gases
They are similar
particles
to liquid, sir.
similar to liquid, but liquids will exert pressure within the liquid. But here, the gases, they will always will exert the pressure on the walls of the container. They want to escape because of high kinetic energy. So they will exert the more pressure on walls of the container. That is the reason. Understand, Mari? What I'm saying? So they will hit each other. The gas particles collide one another, and with the walls of the container, they will keep on exerting more and more force. So the force exerted by these gases, all of you remember, per unit area, that is only we used to call as pressure. So the force exerted by these gases on the walls of the container. All of you remember, walls are very, very far each other, and these particles will collide each other, and they will go and will keep on hitting the walls of the container. Means they're trying to escape from somewhere. So wherever, suppose, for example, suddenly I will put the hole here. What will happen, guys? Every particle trying to escape from the small hole. Is it right or wrong? All of you, guess. Please respond.
Sir.
Yes. So because their kinetic energy is very, very high, so they always exerting pressure on the walls of the container. So whatever the pressure they are exerting per unit area, that is only called as the force is exerting per unit area. What we used to call, guys? Force per unit area, we used to known as something. What is that called as? Pressure. Pressure formula what? Force by area. Understanding? So the air around us is also mixture of various gases. So that you tell me, our air is also exerting pressure or not on us? Everybody. Air is also exerting pressure or not? Please respond. That is only we used to say air pressure, which we used to call as atmospheric pressure. I already taught you. What is the atmospheric pressure value? The pressure exerting on unit area. Understanding? If I take this is the unit area, the air which is exerting the pressure on this unit area is only atmospheric pressure. So how much will be it is? We all knows the value also. Atmospheric pressure
10 power 5
10 power
Pascal.
5 pascals. Understanding? So 1 lakh pascals it will exert on a unit area. That is what air
The
exerts.
atmospheric pressure will be from the outside of the container, no, sir.
No, that is outside the container. Generally, I am discussing. Understand, Mari? Okay. So that is what R else 10 power 5 pascals. You have to remember R, which is equals to 1 ATM. How many ATMs? One atmospheric pressure. That is what equals to 10 power 5 pascals. Okay. So this is what it is. So if you take here gases, now observe very carefully, all of you. Now, why, sir, I am saying you observe all of you how the gases exerting pressure on walls of the container. For example, I will take one bag of, let me take one gunny bag of solids. This is another, all of you. What I am taking? Please respond. Solids. Clear? Now, all of you see that solids will exert pressure, how much it is on the walls of the container. Let us discuss now. So if I have taken the solids. Now, Mr. Kishore will come and will make the hole for this gunny bag. Now you tell me, if I put a small hole here, is it all the, suppose I fill the grains. Is it all the grains will come outside or only some grains will come outside? If I put a hole here, everybody?
So only some grains will come, sir.
All of you? Some grains only will come outside as it is because particles are very closer. So the some grains will come outside. Then slowly by the time the interlocking between the particles will increases. The particles will interlock each other and then they'll stuck at the hole so that you can notice it while you are like removing the salt or something. You can see small hole they won't come. Wheat flour and all. Have you noticed it, guys? Every time we have to we have to shake it more and we have to cut it more, then only it will come out. Is it right or wrong? Everybody, please respond.
Yes, sir.
All of you. That is what? Because the interlocking, the force of attraction between the particles is very, very more. And they will, if you cut the small hole, only some particles will come out. Immediately other particles will come and lock here so that no further falling out the particles out from the container. Now, if I take the, for example, liquid. So now this is the full of liquid I filled. Now, exactly middle I made a hole. Now you tell me how much amount of water will come out. Either entire water will go out or only some of
So no, sir, up to the level of
up to the
the hole
level
it
of
will
the
come,
hole,
sir.
this entire water will come out and the remaining water will be still it is there. So because here also the force of attraction is little bit more compared to solids, it is less, but it is more. But if you take the gas, so gas will be complete closed container only. I made a hole even top. Here I made a hole. Now you tell me what will happen? Only some amount of gas will go or complete gas will be out?
Complete glass will be.
Complete gas will be out. What the reason? They will exert the pressure always on the walls of the container as they are having large intermolecular space and they're having high kinetic energy. They always want to rush out from the container so that wherever they will find a small pinhole also, they will escape from that. Is it okay, guys? Everybody? Clear?
Sir, I can understand gas.
What, Amma?
Sir, gas.
Gases, particles, the space between the particles is very, very high. So they are having large kinetic energy. If they are having a large kinetic energy, the collisions will be more. The particles will hit each other more and they will go and will exert the pressure on the walls of the container. This is the wall of the container. So always they want to go out from the walls. So that is why they always will try to break the walls. So they will keep on applying the pressure, more pressure on the walls of the container. That is what I'm saying. So what I'm saying, like a solids will exert pressure only on the bottom surface, like wherever it is contacting with the another surface. Liquids will exert the pressure throughout the liquid with every particle, But gases, they will exert more pressure on walls of the container because of they are having a large kinetic energy so that they will try to escape out from the container. So they'll keep on pushing
Yes,
applying the pressure on walls of the container. That's all. Is nothing I'm saying. Is it clear, everybody? Yes. So that is what you have to remember it. Okay. So gases exerts pressure. So please write. Particles of gas collide with one another. Particles of gas collide with one another. Particles of gas. Mr. Gokulraj, can you hear me? Collide with one another and with the wall of the container to exert force. The force exerted per unit area. What is to call, guys? The
Pressure.
force exerted, exerted by gases per unit area is known as pressure. Okay. So our atmospheric pressure, the air which is present in our surroundings, how much pressure it will exert? Everybody. Yes,
118.
please. It will exert. Yes, please. How much pressure?
10 power 5 Pascal.
Pascals. Understand? So please make it. Write it quick now. Okay, everybody understood? Now, so this is what. So let us see the percentage of composition. Now, as we know, our surroundings are fully filled with atmosphere. So we all know our air is a mixture of certain gases. And what is the percentage composition? So we all know, so you studied from class 6. Even this composition of air you discuss in class 6 also. But once again, now we are making. So as we know, our surroundings is full of air. So it is mixture of different gases. So first gas, what is a well-known gas for us? Highest composition. How much it is?
Nitrogen.
Nitrogen, 78%.
78%.
Okay. Next, oxygen. So O2, which is actually 20 point, that is what approximately 21%. 20.94 we used to say. Next, carbon dioxide, which we used to say O2. So CO2, okay? CO2, 0.033%. Next, argon. So if I have taken argon is present 0.93%, and other gases all they're present 0.097%. So this is what is the composition of air. So it's not necessary now, but just we are revising what we studied in the lower classes. That's all it is. So please make it. So this is what about what is the properties of gases. I hope you all understand. Any doubt anybody can ask me. Clear, guys? Yes, please.
Yes.
Yeah. So now we are going to study. Next one is fourth state of matter. That is what we all know. What is the fourth state of matter? Let me finish fourth and fifth state of matter.
Plasma.
That is one. Right. So the fourth state of matter. Fourth state of matter. Now, even in our home also, I will give you the example of plasma. So, but you can see this plasma is not existed in the atmosphere. So all of you remember, plasma at the beginning itself, I taught you, plasma will form at extremely high temperature or extremely low temperature. Everybody.
Extremely high temperature.
Extremely high temperature. So all of you remember, plasma is the fourth state of matter. So we know under the normal conditions, we have only three states of matter. Normal conditions, we have only three states of matter. What is that, everybody?
Solid, liquid, gas.
Solid, liquid and gases. But at a very, very high temperature, we can observe the fourth state of matter. So that is only at a very high temperatures, very high temperatures, we can observe the fourth state of matter. So that is only we used to called as, what is that matter name called as, everybody? Matter, which we used to called plasma. Understand? Sir, what is the plasma means? Observe all of you. It is actually composed of free electrons and ions. Okay. So plasma is composed. Of course, we people also can prepare this plasma in our laboratory, but we need extremely high temperatures. So let us discuss now. So it is composed actually of free electrons. What plasma contains? Free electrons and as well as ions. So you all knows ions. When the ions will form, guys? Anybody can tell me? When the ions will form? All of you? when the ions will form? By donating electrons or receiving the electrons? Is it right or wrong? Everybody? Yes,
Yes,
please.
sir.
Yes or no? Others don't know. By receiving the electrons or by donating the electrons, they'll turn into the ions. Now you remember,
Cation, anion.
yeah, ions are two types. That is what? Cation, and another one is what? Anion. Understanding? So if they will donate the electrons, cations, and if they will receive the electrons, what ions we used to say? It is loss of electron. And this is we used to call as what we used to call gain of electron. Okay. Now, if you notice it, as it is, plasma is composed of free electrons and ions, and the state of matter has extremely high temperature. All of you observe very carefully. So particles are having high kinetic energy or low kinetic energy. Anybody's? Extremely high temperatures, more kinetic energy or less kinetic energy? Extremely more kinetic energy. And can you tell me, temperature is very, very high. What is the density? It is having low density or high density? All of you?
Low density.
Low density. Understand? That is what very important. So, matter, fourth state of matter, or you can write this state of matter, has very low density. Okay. So remember, inside the atmosphere, it is the fourth state of matter. But in
Sir, how you can say that it is having low density, sir?
because of high temperatures, particles are having very, very far each other. It is full of electrons and ions only. Understand, Mari? So more number of electrons, free electrons is there. So is extremely high temperature. That is why it is having very, very low density. Understand? Okay. Now you remember, it will be like a super saturated gas, Mari. After the gas, suppose you have a gas. If you keep on heating extremely high temperature, we will get a plasma. That is the difference. So now tell me, is it a gas is already having low density. Now plasma is coming after the gas. Again high temperature. So that it is having low density or high density.
Low, sir, low density.
Understood? That is. Okay. Now,
Yes.
in Earth, this is the fourth state of matter. But if you go to the universe, this is the first state of matter. Do you all understand, everybody? Most of the universe is made up of plasma only. But in Earth, it is the what state of matter? Everybody, it is the fourth state of
Fourth state of
matter.
matter.
So if you take in universe, majority of the universe, if you take the central part of the sun, if you go to the deeper core inside the sun, it is sun is full of made up of this plasma only. So that is why, due to the high temperatures in sun, like sun is also example of star. So all the stars, the atoms of stars continuously keep on break up, and some electrons from broken atoms, they'll be go away from it. So when they are leaving behind some charge on atoms to form ions, so that is why the mixture of ions and free electrons in a star is only known as the mixture of free electrons and ions. What we used to call that? That is only we used to called as. Please respond.
Plasma.
We used to call as plasma. I will say you how it will be happening. So observe all of you. So it is having a very, very low density. So now, if you take for example, solar plasma, means the plasma which is present inside the sun. That is what we used to say at the core of the sun. So the solar plasma has a density of, all of you remember, the particles has about, plasma is about 10 particles, just 10 particles per cubic centimeter. Understand? So that extremely high density or low density, everybody, just 10 particles per 1
Low.
cubic centimeter.
Low.
So that very, very low density or high density, everybody. Solar plasma, check it all of you, just 10 particles. So low density or high density, guys, all of you?
Low
Very,
density.
very low density. That is what you have to remember. Okay. So how it will form, sir? Let me make it. So plasma in universe, as I'm saying, in Earth, this is the fourth state of matter. But in universe, plasma is the what? All of you, first state of matter. Understand? So all the stars and suns, including the sun and all the stars, the core of the sun and the stars is full of, that is what central part of the, we can say, central part of the sun and as well as stars, everything is made up of what? All of you respond.
Plasma.
Everything made up of plasma.
Plasma.
Sir, how it will be happening means, observe, due to the high temperature, be very careful, due to high temperature, okay, so some atoms inside the star, the atoms of the stars will break up. The atoms of the stars break up, okay. So now if you notice it, so what will happen? From these broken atoms, some electrons will be broken, they will go away from it and they will leave the some uncharged, understanding, some charge on atoms and they will form the ions. See that? Suppose this is the atom. Do you all understand, everybody? Please respond. So this is the broken atom. All of you remember? Broken atom. So when because of high temperature, extremely high temperature, okay, so from this atom, electrons are go away. Do you all understand, everybody? Please respond. Electrons are removed. So that if electrons are removed means definitely this atom will turns into ion. What ion? Electrons are removed. It will turns into what ion? Everybody, we all know.
Cation.
Into positive ion. Okay. So let it be, doesn't matter. So due to the very, very high temperature, all of you remember, if I remove the electrons from the gas, then the kinetic energy of the particles because of high temperature is extremely high. That is only we used to call as, that state of matter we used to call as, what we used to call, everybody? We used to know
Plasma.
as plasma. Understanding? So electrons are removed, they will go away from the broken atom and it will leave some charge on atoms to form the ions, and the mixture of these ions and as well as electrons which they went away together we used to called as, what is to say, everybody? Please respond. Which is to called as plasma. Understanding, all of you? Please respond. Now if you
Sir,
take
sir,
the
only
stars,
one doubt, sir.
yeah,
Ions and electrons are, it's found, how, sir, it's found?
how it has been removed actually. Electrons are moving away from the atoms. Understand?
Sir, yes, sir, due to the high temperature of
Yes.
its substance, sir.
Yeah, due to the extremely high temperature, electrons are go away from the atoms. So that atoms will turn
Sir,
into
in
what?
which substance, sir? In which substance?
The matter which is present in the stars. The matter which is present in the stars. Even we can make it with any gas. For example, Mari, I will say you wait. Now Sanjay is asking something. What is Sanjay question? Sir, core contains high pressure and temperature and its inner core layer which has the presence of solid iron and its outer core has molten iron. Yes, Mr. Sanjay, that is earth. Earth core is made up of full of iron. That's fine. But it is also earth, it is not the sun. Sun contains the plasma. It is mixture of gases only. Understand, Sanjay? The core, what you are saying, is the earth core. Okay, Sanjay, not the sun core. Understand, Amma? Sun core is filled with what gas? Everybody. Central part of the
Plasma.
sun is made up of plasma, not iron. Iron is, that is the core of the earth is made up of iron. Is it okay, guys? Understand?
Yes, sir.
Now, so let me
Iron,
take for
nickel,
example,
cobalt.
how to form the plasma is asking. So if I take for example, I am having a hydrogen gas. What I'm having? I'm having a hydrogen gas. So this is the third state of matter. Is it right or wrong? All of you? Third state of matter. Is it right or wrong?
Sir,
Now,
any matter when we
any
heat in
gas,
high
any
temperature,
gas.
it will form.
Yeah, any gas. Now, if I take the
Sir,
H2
any
gas,
matter.
yeah, if I take the H2 gas and I'm keep on heating extremely high temperatures, then the electrons from the hydrogen gas is removed and I'll get hydrogen ions. Plus electrons are removed. That is what? Removed electrons from the hydrogen gas, they'll be together. So that is what we used to call as plasma. Do you understand, everybody? Once the electrons are removed from the gases because of extremely high temperatures, the electrons will go away. Then the gas will turns into ion. That is only called as plasma. The together of ions plus electrons, removed electrons, we used to call it plasma. Understand?
Sir, one doubt,
Any
sir.
gas. Any gas. Any gas. Okay.
Sir,
Another.
only gas, sir.
Yes.
Only gas.
Any gas you can remove electrons from it because of extremely high temperatures. So that is what it will be turns into plasma. Okay. Because solid and liquid means you must, if you want to form the plasma, first you want to make the gaseous state. Yes or no? Do you understand now?
Yes,
Clear?
sir.
That is what. Now, if you take the stars, if you take, this is asking a one more question. Sir, is the only central part of the sun is the plasma? No. If you take the stars, stars are bigger than the sun. Is it right or wrong? Will you all agree with me? Stars are bigger than the sun. Yes or no? So stars, 99% of plasma only. So that is why I said plasma is the fourth state of matter in the earth. But in universe, plasma is the what? Yes, please. Plasma is the what? First
First
state.
First state of
matter.
matter.
That is what you have to remember. Okay. So we can say that the large portion of universe, we can say that a large portion. Sanjay, understand Ra? Earth is made up of iron. Sun is made up of, sun and stars is made up of plasma. Okay. Plasma, which is actually mainly all the stars. So if you take sun is also considered as a star only. So that is what you have to remember. Okay, everybody, clear? Yes, please.
Yes, sir.
Yeah.
Sir.
Any doubt, anybody can ask me.
Sir, I can't
Can you please
understand
down
the
the screen?
What, Shivani?
ions and electrons, plasma,
Nothing,
sir.
Shivani. If you have a suppose gas, if you are having a gas, for example, I'm having a gas. This is gas. Okay, Shivani. Now,
Okay, sir.
if I'm keep on heating, observe, if I'm keep on heating extremely high temperature, this gas will break it into simple atoms. Okay, wow? The gas will break it into atoms. These all are atoms. Okay. Now, because of extremely high temperature, from these atoms, electrons will go away. Understand, Shivani? Electrons will
Yes.
remove. So if electrons are removed means removed or gained. We know that atoms will turn into what? Before itself, I told you. If atoms by gaining electrons or by gaining or removing electrons, they will turn into what? All of you. Yes, please. They will turn into ions. Yes or no? That is what cation and anion. Okay, Shivani. So now electrons will go away. Electrons, negative charge, they will go away. So we will get ions. This is ions. That is what atoms only turns into ions. So we are having ions plus electrons are separated. So this together mix only we used to call it as plasma. That's all. Okay, wow. So if the electrons are removed from the gas, that is what we used to call it as plasma. Okay.
So in the atom, there's only positive electrons.
Not positive electrons. Electrons are negative, amma. So ions will form. Understood? That ion is actually cation. I am saying you. But I am not saying that cation. Electron is removed means they will loss of electron. Loss of electron, what guys? Cation or anion? Loss of electrons. Loss of electrons.
Of electrons,
Yeah,
cation.
remember all of you. Loss
Positive.
of electrons, atom will turns into ion. Which ion? You know, positive ion. Okay, positive ion means cation. Understood?
Yes,
Clear?
sir. Yes, sir.
Yes, please.
Last year, metals and non-metals.
Yeah, metals and non-metals, 8th class you will get it. If any atom will lose the electron, it will turns into positive ion. If any atom will gains the electron, it will turns into what? Everybody. Yes, please.
Negative.
Negative.
Negative ion. Okay.
Anion.
Clear?
Sir, can you please down the screen, sir?
Yeah, I will. Now, if you notice it, that is why the plasma is the more like it is a main source of various radiations and that glare, that is what the brightness from the sun. So if you observe sun, you might be all studied. So many different kind of heat waves will come. Like we'll get UV light, we'll get it.
Radiation.
Ultraviolet light will get it, normal lights, and different variations of various radiations will get it. That is what radiations means, heat waves. So different amount of heat waves will come. This is everything because of, and the sun is appears to be glare. So everything is only because of what? Because of the plasma. Understanding? So because of the plasma only, Mr. Sun is producing the different like source of various radiations. That is what heat and lights, and as well as glare of the sun. So that is what is the plasma. So all the stars also same thing. So write it. Plasma is the source of various radiations. Radiations means different amount of lights. That is what UV light, normal visible light, and all variations, and glare. Kishore Puriyamara, glare from the
Yes,
sun.
sir.
Okay, so this is what about it. So remember, this is only called as fourth state of matter, which is known as plasma. Okay, now, so we are having many applications in this plasma. So let us discuss now. So first, till here, any doubt anybody can ask me. I'm just sliding up. Anything is missing, you can write it. So stars are made up of 99% of stars is filled with what? Everybody?
Plasma.
Last.
Plasma.
Okay.
Plasma.
That is what you have to remember.
So
Right.
wait a minute, sir.
Yeah. Clear?
The core of the sun is made up of
Plasma. The central part of
plasma.
the sun is made up of plasma.
Yes, sir.
Sanjay, understand Sanjay? Now, if you have completed, then plasma in our daily life. Of course, Earth plasma is not existed, but we people can create the plasma, and we are having so many examples for plasma. So let me see that how many it is. Okay, everybody. Shall we start?
Yes, sir.
Right. Plasma in daily life. So meeting is going to end. So let me see. So we'll make it. Lingesh, are you clear? Everything? So now, how many of you know, like, let us see. Practically, if you want to create this plasma, you can all of you notice it. During the lightning and in